Since the dawn of the 21st century, science and technology has made leaps and bounds that range from now being able to edit the very DNA within our own cells to being able to carry around portable supercomputers that give us all the access to any information we could possibly want. Despite these technological advancements, there's still one question that scientists have not quite been able to answer. It has been a subject of debate for students, researchers, and celebrities alike, but no one really quite knows what it is until now. The question you may ask is this: is water wet? Now, I'm sure those of you who are familiar with this question already have an answer in your head, but I want to encourage you to keep an open mind as I give the case for why water is indeed wet. The most common counter-argument I hear is that wetness is not a characteristic of water, it is our experience of water. However, this is not necessarily invalid. You also would have to use that logic to justify why stickiness is our experience of honey and honey itself is not sticky, or that vegetable oil is not slick, slickness is our experience of vegetable oil, or even that fire is not hot, heat is just our experience of fire. But if you think about that, fire is hot because we can use a thermometer to measure the exact temperature of fire and prove that it is hotter than its relative surroundings. So this got me thinking, if we can find a specific measurement to that can be used to compare different liquids and what shows why water feels wet or oil feels slick or honey feels sticky, that would be a compelling argument for why water is indeed wet. The first characteristic I wanted to look at was viscosity, which is defined as a liquid's ability to resist flow. However, viscosity is measured by putting a liquid in a tube and dropping a ball and seeing how long it takes that ball to get to the bottom of the tube. And based on that, you can do some more calculations and you get a specific value. This chart that you see here gives the viscosities for specific liquids. As you can see, there's water with a viscosity of 1 centipoise, which is just the unit of measurement they use to measure viscosity. There's honey that has a viscosity of 2,000 to 3,000 centipoise. And what was really surprising to me is that ketchup has a viscosity of 50,000 to 70,000 centipoise. There's also liquids that I found from outside research, like vegetable oil, which has a viscosity of about 57.1 centipoise, according to the International Journal of Fruit Properties. What surprised me was that oil, which is more slick, has a higher viscosity than water. And after some other outside research, I realized that this is due to the fact that viscosity is related to the size of the molecules, not necessarily their properties and how they interact with each other. So, since oil has much larger molecules, as you can see, than this other water molecules, that shows us that oil is going to have a higher viscosity. And there's also honey, which has glucose molecules in it, which are also much larger than the relatively small water molecules. Unfortunately, this showed me that viscosity would not be the value of measuring wetness that I'd hoped it would be. But luckily, there are two other properties that we can look at that help me on my mission, and they are adhesion and cohesion. According to Khan Academy, cohesion is the property that molecules have when they are attracted to similar molecules, while adhesion is the property molecules have in liquids where they are attracted to different molecules. So you can often see this when cohesive molecules like rain, water, it forms a droplet because it's trying to minimize its contact with the outside area and it's trying to maximize its contact with itself. But when you put it in a glass, water has adhesive forces that pull it to the sides of the glass. So this is due to the fact that certain molecules have an imbalance of electrical charge. So they are called polar molecules, and they have a positive end and a negative end. Water is a polar molecule, so that is why is it attracted to certain solids, to other polar solids. And oil, on the other hand, is not a polar molecule, so it is not similarly attracted. These properties help us see that wetness is indeed a property of water because it is measurable, and we can see that each of these liquids has molecules within it that have these properties, and that is inherently what makes water wet. So some of you may be asking yourself, why is this important? Who cares if water is wet? And I have a simple answer for you. Everyone cares. This question has brought about divisiveness within our world and has split up friends, families, and even entire countries. So it is very, very crucial that we spread the news that water is indeed wet so it can bring about more unity and heal broken relationships. Thank you.